Hello. Hello. Hello.
Hello.
Yes. I'm going to solve some of the questions of the model paper. Okay, previous year papers. In that, some questions are given which we have the same questions we have discussed, but still I want to do it. Some questions. Look at what are those questions. Jacobian is very famous for all the students, but one question is given from the Jacobian in this model papers. So I thought this is important for all the students. So that is why I am doing this problem. You can see the question is if u is equal to x plus y divided by 1 minus xy, comma, v is equal to tan inverse of x plus tan inverse of y, tan inverse of x plus tan inverse of y, find, it is asking to find out Jacobian of uv with respect to xy, with respect to xy. So this is a problem. Sometimes the same question may be in your exam, the same question will be given. Show that the following functions, show that the functions u and this is v are functionally dependent, and also find the relation between them. The way of asking the question is, this is the one way. Another way is we have to show that u and v are functionally dependent, and similarly we have to find out the relation between them. Okay. Okay, so let us start. Solution. Solution. So as I said so many times when I am doing the problem also, what we have to do, we have to develop the relation first of all between these two functions. It means what is our basic requirement, that one we have to do it. We are going to find out the value of Jacobian of uv with respect to xy. So first of all, just to frame the formula. How the formula will be? Can you tell me now? Dou by dou x, dou by dou y, dou by dou x, dou by dou y. The first row will be u and here it will be v. After that, you can see the u value we have to differentiate partially with respect to x, similarly with respect to y, and v with respect to x and with respect to y. That work we have to do it here. What I am doing, I am going to find out the value of u partially with respect to x. Now, if I notice here, u here in the numerator we have x term, denominator also we have a function that is x term. It means we can't simplify it directly. We should apply the formula of u by v. So for your convenience, I am writing the formula. You should be aware about this formula u by v. The variable v will come here in the denominator. This is v square. And first v here, d by dx of u minus u d by dx of v. The same thing we have to do it here. Now look at this is v square. V square means this is our v value, v square. Now v will come here. It is 1 minus xy into derivative of u. U is x plus y. The derivative of x plus y with respect to x becomes 1 minus x plus y must be same, means u will be same. Now differentiation of v. For this term, for denominator, we have to differentiate partially with respect to x. 1 is a constant 0. X becomes 1. So minus y is left. This if you simplify, we get 1 minus xy. Okay. And this is minus into minus plus. And here x into y, xy. Again minus into minus plus y square divided by 1 minus xy whole square. This plus xy minus xy must be cancelled here. We are left with 1 plus y square divided by 1 minus xy whole square. 1 minus xy whole square. Okay. Any student join? No. Okay. Someone please take the screenshot while class is going on. So that is the proof of this class. Okay. Now this value of u with respect to y we have to differentiate. Look at with respect to y. Again same story. Numerator and denominator both of the term will be containing the term y. So the same rule will be applicable. That is v square 1 minus xy whole square. And here what you will get it 1 minus xy only, like the above part, into with respect to y we are doing, that is 1 minus x plus y will be as it is. Now the differentiation of 1 minus xy with respect to y will give you minus x will be the answer. So then if you simplify here only, I will get it 1 minus xy. Okay, this is minus into minus plus x square, and then minus into minus plus xy whole divided by 1 minus xy whole square. So what happened here is minus xy plus xy cancel. We are getting our answer is 1 plus x square divided by 1 plus x square divided by 1 minus xy whole square. This is the partial differentiation of u with respect to y. And now the same thing, that is very, very simple. V value we have to differentiate with respect to x. We don't have the space, so directly I'm doing. With respect to x, tan inverse of x differentiation is 1 by 1 plus x square, comma. Similarly, tan inverse of y with respect to y, we get it. Our answer is 1 by 1 plus y square. Once if you are doing with respect to x, y is a constant. With respect to y means x is a constant. After that, we should take all these values and just put it here under the determinant of what is the first row answer. 1 plus y square divided by 1 minus xy whole square, and differentiation with respect to y we are getting 1 plus x square divided by 1 minus xy whole square. This is the answer of the first row. From the second row with respect to x, that values, the answers are Here 1 by 1 plus x square you will get it, and here you will get it 1 by 1 plus y square. 1 by 1 plus y square, then this is closed, modulus will be closed. And thus determinant of 2 by 2 matrix AD minus BC, this is equal to AD. It means 1 plus y square divided by 1 minus xy whole square. A into D value is 1 by 1 plus y square minus 1 plus x square by 1 minus xy whole square. These all problems are very, very important for the examination point of view. Now look at this, some of the values are again cancelled. What are the values? Here, these two are cancelled. Here, these two are cancelled. And whatever left of 1 by 1 minus x square whole square, minus and minus, this is again cancelling this term, cancelling with this term. We are getting our answer is 0. So I said just now, if your Jacobian value is 0, then we say that Jacobian value u comma v with respect to x comma y will be equal to 0. It means that u and v are functionally dependent, are functionally dependent. And sometimes it is asking to find out the relation is also between them. So to get the relation, what will we do? Okay, next page we'll take for relation. We have v is equals to tan inverse of x. If they are functionally dependent, definitely the relation will be exist between them. Tan inverse of y. This is v is equal to, if you remember intermediate first year formula, inverse trigonometric function, tan inverse of x, tan inverse of a plus tan inverse of b can be written as tan inverse of, actually इसका expansion है, the expansion is x plus y by 1 minus xy. This is equal to, v is equal to tan inverse of x plus y by 1 minus xy. It is actually the value of u. This is the relation between them. मतलब v value is equal to tan inverse of u. This is the relation. So we have shown that Jacobian value, and similarly we have already also shown there the relation between them is 0. 0 is they are functionally dependent, and also the relation. So like that. Okay, I allowed all the students, if anyone is waiting outside. Okay, all the students are there in the class. So I hope you understand. Please, you can text me, you can chat me that if you understand, or you can open your mic and you can just to simply say that you have understand or not. That's it. We are discussing the topic Jacobian, which may come for 2 marks, which may come for 7 marks also. So this is the concept we are doing. Okay, I feel this question is important, so that's what I am doing. Relation, okay, relation, look at the relation. Somebody is asking the relation. For that one, actually we have to use this intermediate formula. The formula will be this one. Tan inverse of A plus tan inverse of B. This is the formula, intermediate formula. Direct x or y may be direct formula. The formula is nothing but tan inverse of A plus B by 1 minus AB. This is the formula. Just we have to put their values in the formula. Tan inverse of A plus tan inverse of B, tan inverse of A plus B by 1 minus AB. That's it. If you don't write the relation also, no problem. Because sometimes they may ask the relation, they may not ask the relation sometimes. Okay, moving to the next question. Number 2, second question it is, find Jacobian of UV with respect to xy. If your x plus y value is equal to u, x plus y value is equal to u, please tell me if anyone is waiting outside. But if anyone is writing anything on the board, on the screen, I will remove from the class. Y value is uv. Okay, so we have to find out the Jacobian value. So what I said, every time when I am writing the Jacobian problems, we should write the relation and we should find out the determinant value here. So we are going to find out Jacobian of uv with respect to xy. With respect to xy. First of all, what I said in the classes also, some number of times, we have to frame the formula. That is dou by dou x. This is the way to frame the formula. Dou by dou y, dou by dou x, dou by dou y. Your first row will be u, u, v, and v, like that, which is equal to. So let me first we fill this one. Means you can find out the derivative of u with respect to x partially. Let us do it here. Our u value will be x plus y. Okay. U value will be x plus y. This one we have to differentiate partially with respect to x. Very easy answer. That is 1 only. 1 plus 0, 1 only. The same story. This value of u partially with respect to y, that is again 1. Now u is done. First row answer we got it. Y is equal to, we have uv here. Again this value also we have to differentiate partially. But here it is not clear. Okay. Okay. Y value is uv. But here v is not a subject. So this implies we can make it now. V is equal to y by u. Because we want to make it v as a subject, then only it is possible to differentiate. V is equal to y by, our u value is x plus y again. Now v becomes the subject. It is convenient to differentiate v with respect to x now. This is equal to, with respect to x means y is a constant, dou by dou x of 1 by x plus y, which is equal to y as it is. 1 by x differentiation is minus 1 by x square. Same thing, the value of v partially with respect to y. Okay, but not getting the space, sufficient space here. So yeah, here I will do it. Here I will be doing the value of v with respect to y. Means you can see numerator and denominator will have same y term. So u by v formula, v square means x plus y whole square. So v will come here, x plus y will come here. Now differentiation of numerator y with respect to y becomes 1 only, minus y into x plus y with respect to y. You get your answer with respect to y means, with respect to y, y is 1. Again, it is 1 only. So our answer will be x plus y minus y divided by x plus y whole square. So plus y and minus y getting cancelling here. We're getting our answer is x by x plus y whole square. These answers we have to just to simply put it here and get the answer, final answer, that is equal to, your first row answer will be 1 and 1. Here 1, here 1. Second row answers are, we can multiply with y, so minus y by x plus y whole square, and then it is x by x plus y whole square again. Now again determinant AD minus BC. So this if we simplify AD, this into this x by x plus y whole square. AD minus into minus plus y by x plus y whole square, which is nothing but equal to x plus y whole square. Numerator is x plus y only. This one square term cancel. 1 by x plus y. This is equals to 1 by. Already we know that x plus y value is u. So the final answer is 1 by u. Okay, like that, this problem will be completed. So I repeat once again, we are doing Jacobians. Okay, any doubt? Please, if you are having any doubt, the doubts are welcome. Or else we can go for one more question. So a Jacobian is either for 2 marks or for 7 marks, but the question is compulsory. The question is number 3. If x is equal to r cos theta, comma, y is equal to r sin theta, then I have to find out Jacobian of xy with respect to r comma theta. With respect to r comma theta. So now once if I am writing the solution, look at that. First of all, we should get the relation. Then that will be working here. Jacobian of xy with respect to r comma theta, which is equal to, can anybody develop the relation between them? Dou by dou r, dou by dou theta, dou by dou r, dou by dou theta. Okay, the first row will be x, x, y, y. So then it means r with respect to x with respect to r. This one we can just do it directly with respect to r. Your answer will be r is becomes 1 into cos theta. Same thing, this value of x with respect to theta. Now in this case r as it is, cos theta differentiation is minus sin theta. Similarly, y value is, okay, this one also we do it directly with respect to r is equal to here. R value is 1 into sin theta. Same value of y with respect to theta now. That's equal to r as it is. Sin theta means cos theta. This is equal to, we shall substitute all the values here. First row answer will be cos theta. Okay. And minus r sin theta. And second row answer will be sin theta. And this is r cos theta. AD minus BC. R as it is. Cos into cos, cos square theta. Minus into minus plus r sin square theta. Now if you take r common, we get our answer is cos square theta plus sin square theta, which is equal to 1, of course. So the final answer of this question is R. We are doing Jacobian. Jacobian will also come in our exam, either for 2 marks or for 7 marks. But the question from the Jacobian is compulsory. Long answer may be asked, it may be coming for short answers. So be careful, Jacobian is also important. This is third unit. Okay, third unit problems we are doing. Okay, let me do it one more question here. Again from the topic, which one I am choosing here? Okay, this is, we can do it one more question. Yeah, the question is again from the third unit. This is third unit question, number 4. I think I should take the next page for this one. The question is, expand f of x comma y. F of x comma y is equal to e to the power of x plus y. E to the power of x plus y using Taylor's theorem. Using Taylor's theorem. About, or sometimes it is given near, about 1 comma 1. So 1 comma 1 is the neighborhood. For this one, we have to write the Taylor's theorem. So what we'll do, first of all, I will tell you how to write the formula by Taylor's theorem. There is a logic also behind the formula. I told the logic in classes also already, but still as a revision, f of x comma y is equal to, because the point is here, a and b is available, this is taken as a and this is taken as b. First to frame the formula, f of a comma b plus 1 by 1 factorial, right? This is x minus a into fx of a comma b plus y minus b fy of a comma b. Now assuming this is a and this is b, so we expand a plus b whole square. 1 by 2 factorial into, that is x minus a whole square into f double x of a comma b plus y minus b whole square into f double y of a comma b plus 2 into x minus a into y minus b into fxy of a comma b plus and so on. Okay, I'm not writing the third degree. Third degree means you can go for 1 by 3 factorial, but this problem it is not required to find out the third degree, because in our question it is not mentioned to go up to third degree. In here we are not getting number of zeros. That's what third degree is not important, not required. F of x comma y is equal to, here we have e to the power of x plus y. Now the first value is done. This implies that We have to find out at the point when x is 1, y is 1. So this is becomes e to the power of when x is 1, y is 1. We get our answer is e square. Now partial differentiation of f with respect to x. So the answer will be again this is equal to e power x plus y. Better if you don't understand, write down the x coefficient, that is 1. This implies fx at 1 comma 1. This is equal to e power 1 plus 1 into 1. So the answer is e square only. Fy of 1 x comma y. Differentiating this value partially with respect to y. Again y coefficient is 1 here. This implies that Fy at 1 comma 1 is equal to e power 1 plus 1. That is equal to e square only. After that we can go for double x value. F double x of a comma b of x comma y, first of all x comma y is equal to the value which is available here already. This one we have to differentiate one more time. So nothing will happen. We get the same thing. X plus y differentiation is x plus y into 1 if you want to write. If you don't want to write, no problem. Double x at the point 1 comma 1 is equal to e power 1 plus 1, which is equal to e square again. Now if double y at the point 1 comma 1, this is equal to again same answer, no change. This implies that f double y at the point 1 comma 1, this is e power 1 plus 1, again e square only. Now fx with respect to y, this is x comma y. Here x with respect to y, yeah, this is x with respect to y, same answer. This implies fx with respect to y at 1 comma 1, this is equal to e power 1 plus 1, that is equal to e square. After getting all the values, simply put it here. Before that, just put the value a as 1 and b also 1 in our formula. This is 1 comma 1. 1 by 1 factorial is 1 only, no need to write. It is x minus 1. Fx at 1 comma 1 plus y minus 1. Fy of 1 comma 1 plus 1 by 2 factorial, it's not 21, 2 factorial 2 only, x minus 1 whole square, double x at 1 comma 1 plus y minus 1 whole square, double y at 1 comma 1 plus 2 into x minus 1 into y minus 1 fxy at 1 comma 1. Put the values. Fxy is e power x plus y is equal to 1 comma 1. The answer is e square plus x minus 1 into fx at 1 comma 1, again e square plus y minus 1. Fy of 1 comma 1, again e square plus 1 by 2 factorial, 1 by 2 only, x minus 1 whole square, double x e square plus y minus 1 whole square, double y e square plus 2 into x minus 1 into y minus 1. Xy answer is again e square. Your choice is there. If you want to take e square common, choice is yours, or else you can just leave it here. That is also the answer of this question. So this is the problems we have done today. Starting with this slide, you can see anywhere if you feel the problem, difficulty, anywhere, just tell me. Athia is there in the class. Athia, you can just take the screenshot of this class and just send it to me. How many students or participants, how many are there?
Okay, sir.
This is the page number 1. This is the page number 2. And the remaining part of differentiation of V with respect to Y is done here with the pink color. Okay. This is the page number 3. This is all about Jacobian again. And then finally, this is page number 4. This is all about Taylor's theorem. No doubt. Yes. Okay, thank you then.
Thank you, sir.